Hi, thank you for taking your time for our session. It is titled ML Ops Best Practices on Google Cloud. And we will have 4 speakers for this session. So I'm Kaz Sato, I'm from Google Cloud, and we will have Zia from the Cloud AI platform. And we also have the Robin and Fabien from Atos, who is the Google partner company. If you have any questions, please use Story. So you can use the Cloud Next app on your smartphone and tap this session and use Story questions Q&A to ask any questions. And these are the topics we'll be covering in this session. So I will discuss what is ML Ops first. And also I will discuss how we can build the CI/CD, continuous integration and continuous delivery for the machine learning production systems. And then Zia will talk about the portability and hybrid deployments and lifecycle management. Lastly, the Atos team will talk about how they were able to bring the ML Ops practices into the production machine learning system. So what is ML Ops? This is a quotation from the one Google software engineer who has been operating one of the largest machine learning systems in the company for over 8 years. He said, launching the machine learning system is easy, but operating the system is the hardest part. So he has been operating the largest machine learning system for 8 years, and he faced many, many different challenges during the operations. So continuous operation is the hardest part, he said. And there are so many different problems you'll be facing. And we thought the practice of the DevOps may help us. So what is DevOps? The DevOps is all about unifying the dev and ops, and especially focusing on the automation and monitoring. So you can apply the same concept when you are building the production machine learning systems. So we call it ML Ops, DevOps for ML. DevOps for ML. And so it's all about unifying the dev and ops of the machine learning systems, especially focusing on the automation and monitoring of all the machine learning pipeline phases and the operational phases. And it's not only about the operation team, but it's a culture and practices that you should share among all the stakeholders in the machine learning systems, starting from the researchers, data scientists, data engineers, or operation team, and also product manager and business people. Everybody should understand what are the practices and the culture to build a scalable and robust systems. By the way, how many people are the researchers and data scientists here? Or about the 50% or maybe 40%. Who are the DevOps people or operation engineers? Or maybe I see the overlaps here. Who are the product managers or business people? Maybe 20%. Thank you so much. So you all have to build a robust and scalable teams by sharing the practice. And this session will be focusing on those topics. I will talk about data validation and modular analysis, and Zia will talk about portability and hybrid deployments and lifecycle management. So let's get started with the data validation part first. This should be happening at the preparation phase of the ML pipeline. After you collected all the training data, you have to do some preparation or pre-process for the data. The pain point we have been hearing at this phase from the customers or internal engineers is the CI/CD, continuous integration and continuous delivery. Because in the traditional IT systems, people have been writing millions of the unit testing code to make sure your production system works as intended. But with machine learning systems, the behavior of your system is defined by your model that is trained by the training data. What kind of tool you can use to make sure your system would work as intended? We cannot write the unit test code anymore against the machine learning model. And there's another pain point called training serving skill. This is caused by any differences between the training and serving. For example, if you are using the training data and there's any differences against the serving data, you should be watching the drop of the accuracy. Also, you could use the different ways of how you can pre-process the data for the training and serving, or you could have the hyperparameters. So all of those changes can cause the accuracy drop in the serving system. So we have announced the new product called TensorFlow Extended, or TFX, a couple of years ago that could be a solution for these problems. TFX is an end-to-end open source tool for deploying production machine learning system. And TFX has many different components and features inside it, but I'd like to focus on the one feature in this session, actually two features. One of them is the TFDV, TensorFlow validation. TFDV allows you to understand, validate, and monitor the training data at scale. Actually, at Google, we have been using this for our production systems for validating the petabytes of data every day. So it's a proven product. And this is a quotation from the TFX paper we have published. We want the user to treat data errors with the same rigor and care that they deal with the bugs in code. So if you have any errors in the training data or any unexpected distribution in the data, that means that could cause the bugs in your system. So data is the code right now for the machine learning system. Actually, Google Play team was able to improve the application install rate for the 2% just by introducing the data validation concept. Let's take a look at the short demonstration video of the TFDV. So you can open your notebooks. Here we are using the Chicago taxi trip data set for the training data. So we are executing the BigQuery SQL inside the notebook. And the table has the features such as timestamp or trip seconds or miles or tips and fares. Our model is to predict whether the customer would pay the tips for the 20% or not. And by using TFDB, you can easily looking at the statistics and distribution of each features. For example, if you're taking a look at the feature for the payment types, you can easily show the histograms and distribution against each category, is it a cash or credit card or no charge, and so on. And that was the statistics for the training data. You can also compare the statistics between training data and evaluation data. So in these charts, you are seeing the red bar charts here. These are the statistics for the evaluation data. So you can easily compare the difference between the training and evaluation data and find out what would be the reason why you are not seeing the great result with the evaluation data. Maybe it's because the trip miles feature has the great difference between for the statistics. You can also find the training serving skew with the TFDV. You can find the schema skew or the feature skew or distribution skew. You can just call the API of the TFDB to find out those skews instantly. So these were the features, functions you can get with the TFDB. Let's take a look at another feature from TFX, which is TFMA, Modular Analysis, that will be happening at the test and analysis phase. Because we have been hearing many the pain points from the developers or internal engineers that any machine learning model can get stale over time. So one scenario could be like this. So your model accuracy would be slowly going down. It could be day by day or week by week or every quarter or every year. It depends on the characteristic of your model. But if there's no practice for the continuous monitoring of the accuracy, the end users would be the first people who notice the downgraded the user experience or the dropped accuracy. And the business team would notice that, and your director would ask you to update the model ASAP. And we don't want to see that kind of the situation. So this is where you may want to use the TFMA modular analysis This tool allows you to evaluate the metrics of your ML models. And you can specify the quality thresholds, and you can make sure that your system is working as intended. And TFMA allows you to take a look at the changes of the accuracy or AUC or any other metrics for the different time points. So you can easily find the derivatives of the accuracy between the different time points, timestamps, so that you can define the refreshment requirements of your model, whether you want to retrain the model every day or every week or every month and so on. You can also define the sliced metrics with the modular analysis. The sliced metrics means you can define the different segments in the whole data set. For example, your model could be working so well for the people in the United States, but it's possible that your model is not working well for the people in the Asian countries or European countries. So those geographic locations could be one of the examples of the slice of the metrics. Or you can use the time of day as the slice. So model is working well in the daytime, but not so working well in the nighttime. So not only looking at the single accuracy number of the whole model, you have to looking at the multiple accuracy model by defining the multiple segments of your data. Let's take a look at the module analysis video. So again, this is a Chicago taxi data we'll be using. You can easily install the TFMA in the notebook by clicking the cells. And by calling the API of TFMA, you can visualize the accuracy changes of the model. After defining some schemas and slices, I have skipped it in this video. So you'll be seeing the user interface, the visualization, where you can see how the matrix can be changing by the, in this case, it uses the trip start hour, the hour in a day as the slices. And you can also change the matrix to the accuracy to see the, you can see the changes of the accuracy in a day, like this. And you can also change the metrics to the other matrices, such as the prediction, precision, and recall, AUC, and so on. Now the graph is showing the precision values for each hour. So that was the features you can get with the TFX to build your own CI/CD systems for the production systems. Here, now I'd like to pass this stage to Zia, who will be talking about the machine learning portable and hybrid deployments.
Good afternoon, everyone. My name is Zia Syed, and I'm a senior manager in the Cloud AI platform team. First of all, thank you, Kaz, for giving us a wonderful introduction to TFX components and how you can use them for CI/CD and build high-quality machine learning systems. So TFX team has done an amazing job at building these state-of-the-art machine learning components and open sourcing them. But the truth is that putting these components into production, you still have to do a lot of work. There are considerations around security, data access, scalability, monitoring, logging. And that's where Cloud AI platform comes in. And one consideration that is increasingly becoming relevant is the hybrid and multi-cloud nature of the deployments that our customers have to deal with. So before I tell you how you can use these TFX components in end-to-end machine learning pipelines, let's take a step back and let's talk about hybrid deployments and what are the challenges that data scientists and ML ops people face in those hybrid deployments and how Google is trying to address those. So hybrid deployments are a fact of life. There's a good reason this is a theme for our Google Next event this year. There are multiple reasons where companies are running into or running hybrid deployments. Could be legacy, strategic, could be jurisdictional reason, could be edge compute reasons. You may want to use the cloud, but you still want to have some compute running close to the application's edge. So that's why, by structure of the application, you have to still have a hybrid deployment. And lastly, for just using best of the breed services in the cloud that are just not available on-prem, you may want to have a system which uses which basically spans a public cloud and your on-prem deployment. Just to get a quick show of hands, how many people here actually have to deal with hybrid deployments, which are both, let's say, on-prem and one public cloud that is out there? So quite a few, probably I would say 25%. And any audience members who actually have to deal with multi-cloud deployments, where you have a multi-cloud strategy? So still, I would say probably 5–10% of the people. So according to the analyst estimates, 88% of the enterprise will eventually adopt a hybrid cloud strategy. But as the way things stand today, only 80% of the workloads are actually in the cloud. So this means there's a lot of work that needs to be done, and part of the reason is managing hybrid is hard. And that's where Google Cloud AI platform has been investing heavily in. So hybrid is not new to Google. Google, of course, open source Kubernetes and has been supporting it heavily. But Kubernetes, as we know, is not aware of, it's basically application agnostic. It does not know what machine learning is, what training jobs are. So that's where Kubeflow comes in. It builds on the hybrid capabilities of Kubernetes, and it's a platform that you can use to develop, deploy, and manage scalable end-to-end machine learning workloads. So if you have a Kubernetes cluster on-prem, you can deploy Kubeflow on top of it, and it will give you, right out of the box, ability to do distributed training, prediction. It has multi-framework support, and it is well integrated with the stack driver logging. So you don't have to do the whole work of figuring out which versions of these components to run and which work well with each other components, because machine learning deployments are complex, and it's not just like a one process running. It's a set of services that have to run and work and collaborate with each other. Today, we also announced Cloud AI Platform, which essentially is a managed equivalent of Kubeflow on the cloud. So this is something you can use on GCP's console, and it's basically an integrated development environment for data science and machine learning on GCP. But how do these two things come together to provide a comprehensive hybrid solution for people like ML Ops who are managing the solutions? So let me just walk you through an architecture diagram. So imagine you have an on-premises deployment cluster. You can use Kubeflow, and you're running Kubernetes. You can use Kubeflow on top of it, and it will, out of the box, gives you training and prediction services, and you have a Jupyter Notebooks backend, so your data scientists can launch their Jupyter Notebook instances, and also machine learning pipelines runtime that I'm going to talk about later in the talk. Okay, so AI platform is the equivalent of Kubeflow on GCP. It internally leverages Kubernetes and to a certain extent Kubeflow, but it eventually gives you the same training and prediction services on a managed a cloud offering. So on-prem, the customers or the ML Ops teams are responsible for providing DevOps support. And on cloud, Google basically provides the DevOps support. And your data scientists, their lives are mostly spent using Jupyter and writing Python code. And that poses a challenge because as of today, the training and prediction services that you're running on-prem and on GCP, they don't have same APIs. And that's why data scientists have to learn two different set of APIs. So today we are also announcing what we call a hybrid ML SDK. It is part of the Kubeflow open source project. Its official name is Fairing. What it does is that hybrid ML SDK understands the intricacies of each particular development environment. It knows which APIs to talk to training service running on Kubeflow versus training service running on AI platform, and it abstracts out those details. And so data scientists only have to speak one language, and that is the language that hybrid ML SDK defines for them. And in addition to abstracting out the API details, this SDK also handles the details of how to package code for remote execution, so how to build containers so they can be submitted to a Kubeflow cluster for execution or to AI platforms training service for execution. So just for a little bit, again, definition, so Kubeflow Fairing is an open source hybrid machine learning SDK for data scientists to write ML code once and run anywhere. So this falls in line very well with our broader strategy in cloud to provide write once, build once, and run anywhere strategy. So let's take a look at a code example. This is where the data scientists have to deal with this highlights the three different ways data scientists will have to deal with three different environments. One is local, which is their notebook. Second is building and deploying to AI platform, which is a managed machine learning training and prediction service. And third is Kubeflow. In the first case, they're dealing with Python, simple enough. They just write some Python code for training and prediction and then execute it. For deploying it to a platform, they have to integrate with G-Cloud command line API and provide all the dependencies and all the packages that need to be installed before their code can execute on AI platform. And lastly, if they want to use Kubeflow, they have to speak Kubernetes API. They have to specify a YAML file and then execute it against Kubeflow. And as we talk to the data scientists, we realize that this is not something that they're excited about learning, or this is something that becomes a major hindrance for them to adopt or get benefit from these hybrid deployments. So with Kubeflow Fairing, the code kind of becomes similar across all three deployments. And you can basically write code once and run anywhere, but there are slight differences. And let's just focus on those. So first of all, as I said, rest of the code is same. But there is this thing called a backend definition, which goes as an argument to the training job object. And you can there define what backend that you want to use. Is it a local backend? Is it a backend that is managed by Google in the cloud AI platform? Or is it a local on-prem Kubeflow deployment? So, and these names, local AI platform, they're basically strings. You can imagine this could very well be dev, staging, or prod. And there can be many definitions. And these backend definitions can be managed by the ML ops teams. So, and that is done by this config file called fairing.config. And you can have multiple config files, and you can define the backends that your data scientists can talk to. You can control things like what base containers your data scientists can use before Fairing builds a container and ships it to the backend training service for execution. So just to go through quickly what Kubeflow Fairing offers, it's again a data scientist-focused SDK, and it is multi-platform, and it is scalable and cost-effective. It also provides inbuilt feature for you to burst into cloud. So if you have workload that you can, it's hard to package and execute. It makes it difficult for the data scientist to package that code and leverage, let's say, thousands of GPUs or hundreds of GPUs in the cloud. So Kubeflow Fairing hides those details from you and provides same API, which naturally helps with bursting also. Lastly, it supports the full machine learning life cycle, and it supports multiple frameworks. Today we have full support for XGBoost, and TensorFlow and PyTorch can be run in a single node fashion. Part of the reason is that this is a nascent project, and it is also open source. So if the audience members want to contribute to it, they're welcome to join and start contributing to this project. Let me show you an end-to-end demo that will show Kubeflow Fairing in action. But before I go there, what I'm going to do is that I'm going to go to this new service that we have launched. It's called AI Hub. AI Hub is like your one-stop shop for everything related to your machine learning resources within your enterprise. So you can find notebooks, embeddings, models. And then I'm going to deploy it on Jupyter Notebook service. This is also a new service that we are launching at this next. It's a managed notebook offering, so you can run your Jupyter notebooks in the cloud. And then we are going to train it on 3 different environments, local AI platform and Kubeflow, and then we will deploy it back to a prediction service in the cloud. So this is the AI Hub's main page or search page. So I'm searching for a cancer detection notebook. And as I press enter, it shows me 4 different assets. 3 of them are notebooks. 1 of them is actually a model. So what I'm looking for, this notebook, Karthik's cancer detection demo that was created by my colleague and shared with me. So I'm going to click on it. It will take me, and I'm going to open it in GCP. It is going to take me to the managed notebook service. I'm choosing a notebook instance where I want to launch this notebook. So this notebook, first part of these notebooks are pretty straightforward. You're setting up your environments as you would do for a regular notebook or any generic machine learning job. First, then you can set up your readers. You want to explore the data. You want to visualize it, make sure that everything looks right on the visual inspection. Then so these are some positive and negative sample for breast cancer detection. Then you build your model, you specify your feature engineering, how you're gonna create image embeddings, what kind of model you're gonna train, and this is the location of the output model. This notebook is also referring back to the AI Hub or TF Hub to use a particular feature embedding for our images. And this is at the end, this is the train function that we're going to use. So let's take a pause here. So these are basically 3 different kind of training that I'm going to execute. One is local training. I'm going to call the training method directly. Then in Kubeflow training, we're going to call it as part of this train job object and submit the job. And I'm going to use this Kubeflow GKE backend for this. And for the last one, which is AI platform training, I'm going to use a specific backend, which is the GCP managed backend. Oh, sorry, I reversed it. So the first one is Kubeflow training, and the second one is AI platform training. So let's execute the local training first. So you start the training, and you get the regular log in your notebook, and you can see how the training progressed, and it took like 184 seconds, and it shows you all the loss and accuracy metrics. Now you can execute this exactly same training method using Kubeflow Fairing on Kubeflow, and when you play it, it is now basically first packaging your code and building a container and sending it off to your local Kubeflow cluster for execution. So you can see that it is building a Docker image here. It puts into a local container registry, and then Kubeflow can basically pull it from there. And so you can see, even though this container is being executed remotely, the logs are being streamed back right into your notebook, so you don't have to go anywhere special for that. So you're still in your familiar environment of notebooks. Lastly, for AI platform training, you do exactly the same thing. One difference is that once the containers are built and are submitted to AI platform training job, the logs will start going to your Stackdriver service, and what we do is that we provide you a URL that you can use. You can copy paste it to, you can take the job ID, you can take it to your Stackdriver logging console and search for the logs and monitor the same log that you were seeing inside your notebook, in this case, on the managed service. So I will pause this. I will move to the next slide. So again, the key benefits for the Kubeflow, for the ML Ops team who are using Kubeflow Fairing, is that Kubeflow Fairing standardizes the APIs for data scientists, and which allows the ML Ops teams to enforce best practices. So it's not like one data scientist is building their containers one way and the other is doing the other way. They are all using the same method, and that allows you to say, okay, everybody is going to use the same base containers and execute the machine learning workloads that way. Second is open source means that is no lock-in. If there are other backends that you guys or your teams have to support internally, there is always a room to add those, and it's all built on open standards, so nothing hidden. Again, it's core part of the Google's open and standardized strategy. And lastly, it provides you easy bursting and remoting to the cloud. So now I will spend a little bit more time into how you can use machine learning pipelines, or basically expand more into end-to-end workflows. So Kaz mentioned these 2 components, data validation and data analysis. So we'll talk a little bit about how you can use these components into end-to-end workflows. And people who have built these end-to-end workflows, they know that this space is very fragmented, and it's really hard and costly to build these systems. There are too many options out there. Some people are building these machine learning workflows using Airflow. Others are using Argo. And some people actually go ahead and build their own homegrown solutions. In my past life, we used both Gearman and Airflow to build these pipelines, and it was not easy. So, and the second part is that these machine learning workflow systems are not aware that you are actually doing machine learning. They're very generic systems. So for example, for things like reproducibility, which is important for machine learning workloads, it's very hard to achieve that goal using these, I would say, workload agnostic workflow orchestration systems. So a bunch of customer pain points around, first of all, there's so many options that they don't even have to worry about reproducibility. They're just tracking how many tools and techniques people are using in their companies to run these workflows. And second one is they only update and run their model every 6 months because it is so hard to train it every single time. So Kubeflow Pipelines enable developers to build a custom machine learning workflows by stitching together these components. And you can think of those components as building blocks. And each component, or which you can call an ML task or ML operator, is basically a containerized, is basically a container that provides you reportability, repeatability, and encapsulation. And you can, each step of this pipeline or each component can run individually on the host or wherever you're running those pipelines, or it can call into remote services, let's say Dataprog, Dataflow, or AI platforms training and prediction services to leverage remote, to leverage the resources in the cloud. And we provide you a library of pre-built components to build your pipelines, but customers can also can define their own ML tasks to expand the capability of Kubeflow pipelines. And then, so just to show you some code, so basically you then use Python to define your own DSL, how you're going to stitch together these components to create an end-to-end pipeline. And also you specify the parameters which will make this pipeline instance when you instantiate it unique. So just to take a quick example at the quick look at the example, this may look a complex example, but it's essentially a Python function with a bunch of input arguments and a decorator. So the decorator is specifying that this is a pipeline's DSL description, and you specify your name and description for this pipeline. Then the input arguments of this function are essentially the parameters that you specify. They have some default values, but when you instantiate a pipeline, you can override these defaults and point to, let's say, a different data source when you're actually executing this pipeline. And the third part is essentially a specification, or the body of the function is a specification of the pipeline steps. So you're specifying, let's take a look at the line number 2, which is a TF training operation, which takes the input from the pre-processing stage and also produces its own output that you can then provide as an input to the next stage, which is Dataflow and TF model analysis stage. So we will have another session tomorrow morning where my colleague Anand is going to go deeper into this, to pipelines and talk into more detail. If you guys, this session is already full, but you're free to watch it online or later. But that session will go into further details here. This is visualization of a Kubeflow pipeline. Same pipeline that we defined here, and it's a UI. So you have a bunch of stages: validation, pre-processing, training, prediction, analysis. And if you click on, let's say, the analysis component here, and you see the slicing metrics that Kaz was mentioning earlier, so you will remember that this analysis component is essentially the same TensorFlow model analysis component that Kaz was talking about earlier. So we have containerized those and make it super simple for you to stitch those components together into a generic pipeline and run them both on-prem and in the cloud. So just to wrap it up, Kubeflow pipelines enable workflow orchestration, enable rapid and reliable experimentation, and also provides you a unit of execution that you can share, reuse, and also further compose with other pipelines and make more complex machine learning workloads. With that, I will pass the mic to Robin, who's going to talk about how they deal with hybrid machine learning workloads in their own operations.
Thank you, Sia. So my name is Robin Zondag. I work at Atos. I'm global head of AI labs, and I'll be talking to you about why these technologies, these Kubeflow technologies and the whole family around it is important to us, and what our experiences are in the practical demo, which Fabien, who's standing next to me, will show to you. Maybe, yeah, it's moving. Maybe a little bit about Atos in case you don't know us, and what are we doing with AI, ML, and then we'll move to why this is important to us. So Atos is number 5 in the world in digital services company. We employ about 125,000 people. Number 1 of the leaders in Europe, and growing very fast in America. We entered a strategic partnership with Google last year, and one of the key drivers was AI ML. We have the same vision on it. We believe, like Rajan was saying this morning in the keynote, that the technology is really ready now to make impact on all sorts of organizations. And our tagline, and we think what we want to do, is make AI real for business. So that is what we're all about. What we're adding to that is we think it is a great new technology and all sorts of technologies, but how do you change business? How do you build an AI-driven airline? That's what we want to imagine, go innovate with our customers. That's why we set up AI labs in London, Paris, Dallas, and Frankfurt will be opening soon, which is the imagination part of it. So we'll discover what's possible with the data of the customer. We will design a use case that you can actually implement and define the AI journey with customers. To make AI real for business, you need people that understand how to build these solutions and how to deploy them. So we are rapidly certifying our forces into Google Cloud technologies and make sure we can help our customers by our own resources and by Google PSO. And of course, the last piece of it is using the right technologies. We're using the GCP platform, adding our own accelerator, the SynBots acceleration platform to build things faster, and Codex AI Suite, which is our own technology that works with supercomputers and allows you to build AI programs in that sense. For us, there's basically two key drivers why we're interested in this technology. One is the hybrid cloud. We strongly believe in the hybrid cloud, and it makes it much easier to build great AI ML products in the hybrid cloud. And the other one is productivity of AI ML product teams that is really supported by this new technology. So let's have a look. So the hybrid cloud, we've heard a lot about it. This conference, it was the opening, Anthos announcement. We also, actually, Atos announced that based on Anthos, we announced a hybrid cloud that is extended with some management tooling and specific security solutions for our customers. And actually, when we look at our customers, we see a lot of reasons and a lot of customers, with hundreds of customers around the world, that are moving to the hybrid cloud. They love the public cloud. They love the scalability, the cost advantages sometimes, the innovation, agility that is, and all of the functionalities that are offered by the public cloud. But they do have their existing build up in years base systems that are a bit reluctant, and that will take a lot of effort to change. So let's look at different customer groups and see what that drive is to go to hybrid. So take banks, for instance. Banks typically have legacy systems that are essential to their core business processes that are not so easily transported to the public cloud, and the benefits are less as well. The other thing typical for banks is they have sensitive data, your payment details, which cannot be shared with others and have to be protected, or are protected by strict compliance frameworks that are legally available. Look at hospitals. Their key consideration between on-prem and going to the cloud is the sensitivity of medical data, even more sensitive than payment data. Some other, for instance, research institutes like universities, they love the computational power of the public cloud, but they sometimes need in their high-end R&D real-time simulation where actually the compute power needs to be close to the experiment. So the latency is something they cannot handle. And last but not least, I'll look at the manufacturing. A key thing for any manufacturing boss is to make sure his plant is continuing to produce. So anything that could cause failure or stop production is something that is really to be avoided. Therefore, introducing the internet as a single point of failure is something people are really concerned about. Next to this rational arguments for balancing the cloud public cloud and the hybrid, there's also some emotional consideration we see at our customers. So it's trust. Do I trust the suppliers enough to really be fully dependent on them? Control, I want to be in control. And also the very human resistance to change, because it's a big change for many organizations. So anything that makes it possible to build products on the hybrid cloud, which we expect to be here for the coming years, is really of interest to our organization and our customers. Building ML pipelines should be as easy as possible. We employ around 10,000 people in this domain: AI experts, data scientists, data engineers, data warehouse experts, platform engineers, integration specialists. So if we can find ways to make them more productive, you can imagine you have our ear. And if you're credible with a story, we're really, really interested. That's why we started engaging with Google on this one. If we go through the life cycle, what is really interesting, we found, so starting a model, building your models, defining the first things you might do in your own notebook. This is where what Kaz was talking about, the TensorFlow X suite is really helping to detect the predictive value of the data, to see and understand how your model is learning, and also to detect and determine the performance of the model. And then it helps the Kubeflow technologies, the pipelines, if you need compute power, to move it easily from your own notebook into the public cloud, where there's a lot of heavy lifting possibilities. The second phase, once you have a great model, you don't have any business value yet. It needs to be deployed. It needs to be made part of the IT landscape, but it needs to get to the end users that actually use the insights out of data. So the faster, the easier, the more easy you can do that, that is really beneficial for companies like ourselves. And the Kubeflow technologies, the family of Kubeflow, really help to make this happen. And actually speaking to some data scientists that weren't so concerned about deploying the thing, but were much more interested in the models, the data scientists and AI experts can continue to use the tools they're using. So they're not noticing that this is actually happening. And last but not least, once your model, once your solution is in operation and the business users are getting the business value, you have to maintain it. So all of the operations management functionalities are important to continue. That's what's being supported. You have to know as an operations manager that this model is still predicting in the right way as the world is changing. And you'll need to know as well how to make some changes, which is supported with Kubeflow Pipelines. So the promise is really interesting for us, and the great thing for us in working with it and experiencing Kubeflow is that that promise seems to be, based on our current experience, also really, really happening. So let's go, without much further ado, to our case. We really worked with a customer. It's a European customer responsible for land registry, cadastre, and it needs to make all the changes that are happening in real life. They use satellite images to see what's really happening. And they have a team right now that manually, and it takes years, adopts all the maps they have based on the satellite pictures. We suggested to use deep learning to make the change. And over to Fabien to show us what that looks like. Thank you.
Hello. So my name is Fabien Silva, and I'm an expert in the Business Center Data Analytics and Artificial Intelligence in Worldline, an Atos company. So in this talk, I will quickly present you the approach we have chosen to tackle this problem and why and how we use Kubeflow Pipeline for that. So in fact, the main reason that we like using Kubeflow Pipeline is because it makes the work easier and more efficient. We can iterate faster, and the data scientists don't have to take care about setting up the environment where the code will be executed. So as you've seen previously in the talk, Kubeflow Pipelines can do a wide range of DevOps scenarios, but today I've chosen to focus only on the early stage of the project when you start training your first code prototype. And the sooner you start using Kubeflow, the better it is. So without entering into the details, this use case reminds us the work of Philippe Aizola and his team in 2016, and it's image-to-image translation with conditional adversarial networks, so that's deep learning. And we wanted to implement that approach with TensorFlow and then be able to iterate on top of that. So in this talk, I will show you 3 things. Number 1, I will show you that the impact of writing code that is compliant with Kubeflow is very minimal. In fact, you can still run that code anywhere else with or without Kubeflow. Number 2, I will show you that how to quickly prototype a Kubeflow pipeline. And number 3, I will show you how you can remotely execute a Kubeflow pipeline, for example, from this laptop onto your cluster in GK. But before, let me give you a first high-level overview of the code base. So basically, the project structure is divided into 3 components: download dataset, prepare dataset, which transform the JPEG images into TF record files, more suitable for TensorFlow. And then we've got the train pix-to-pix, which build and train a generative adversarial network. So here, these 3 tasks are defined in dedicated Python functions, and each of these functions have a separate Python file for convenience. So let's move it to the code. So JupyterLab is running locally on a MacBook. So this notebook, there is nothing special. In fact, it's just show that we can use that code locally and just call the simple function that we've defined, prepare dataset here, and train pix-to-pix here. So it's already trained. This code can run on Kubeflow or on a system without Kubeflow, even on this laptop, provided that I use a small subset of the dataset, of course. So if we have a closer look at the download dataset, so this function is pretty simple. In fact, there is only one single line of code that is really useful to download the dataset and the dataset archive. And but it's interesting because it's easy to show you what is important to do for your code to be compliant with Kubeflow pipeline. So basically, all the code is self-contained into a top-level function, Python function. The second thing is to take care to include all your libraries inside that function. And the third thing is to explicitly specify the input and output parameters of that top-level functions. And so this is a very simple task. And by just doing that, your code, you can still run it locally on your cluster, and you can also use it on a Kubeflow server. And let's move to Kubeflow. So now I will show you how I can reuse that code, so the 3 Python functions that we have defined in a similar way, to build a Kubeflow pipeline. So for that, we re-import our Python function. We also import the Kubeflow SDK, Kubeflow Pipeline SDK. And then we will convert our Python function into pipeline operation, and this is done by just calling this function from the SDK and passing in argument the Python function that we have defined. We also specified a Docker image because Kubeflow pipeline will execute that code inside the Docker image using inside the Docker container using that image. So the second step is to build the pipeline workflow itself, and this is done by defining a Python function. So here is the function. We add a decorator. We specify the input parameters of the pipeline workflow. So that looks a little bit verbose, but it's more easy than it looks. And then the Python operation that we have previously prepared will be used to compose the pipeline workflow. So here I start with the download task. We choose the download operation, use some parameters. Then the preparation task, use the preparation operator, reusing the output of the previous task. And same thing for the training task. Once you've done that, you compile your pipeline. And the final and third step is to create and execute your pipeline. And for that, you instantiate a Kubeflow pipeline client. You create or reuse an experiment. And you execute, I will execute it, and you run your pipeline. And normally, if the network is fast enough, we should see that a job should be running. By the time it's loading, I think I will move to the next one. So here I'm back locally on the Jupyter notebook running on my laptop. And the idea is to re-execute the same code. So this is exactly the same notebook as previously seen, but this time we will execute the code on the cluster, so a remote execution. In order to do that, I've prepared some authorization. So basically, I've got an environment variable defined on my laptop that point to a JSON key file with some credential for the GK cluster. The rest of the code is exactly the same as the previous one that I've executed. So with the import the SDK, define the operation, build the pipeline, similar way. The novelty, we compile the pipeline, same thing. The novelty is when we instantiate the client, the Kubeflow pipeline client, I pass two other parameters, and especially the endpoint URL of my cluster. And if I do execute that, network is a bit slow. Okay. So now we should have two jobs running. So
already over time, I guess, what we will do is that we will stick around. We don't have time for questions, but we will stick around in the back of the room. If you guys have any questions, please come to us. We'll be happy to chat with you guys. So we'll be there for the next 20 minutes or so. So thanks a lot for coming, and really appreciate it.